This is Module 3, Lesson 8, where we'll be starting to talk about what makes figures similar to each other and determining and proving whether those figures are similar. And if you recall from the first few lessons of Module 3, we talked about the actual idea of being similar. And when two figures or several figures are similar to each other, they're the same shape, but not necessarily the same size. So here we have triangle ABC, this larger triangle here, that's been dilated from center O by a scale factor of 1/2. So it's been shrunken by 1/2. It is noted by A prime, B prime, C prime. You also have triangle A double prime, B double prime, C double prime here, which is congruent to the prime figure. We need to describe a sequence of basic rigid motions plus a dilation that would map the double prime figure back onto the original figure. So we're going to use what we talked about in Module 2 along with the idea of dilations. So I'm going to create a vector from A double prime, I'm going to create a vector on the correct points. I'm going to create a vector between the B points, B double prime and B. And I'm going to use that as a translation. So I'm going to say that I would translate triangle A double prime, B double prime, C double prime along vector B double prime B. I have to name it in that order because that's the order that I'm going to be going. So if I were to take a transparency and show that shift, I would get a triangle that looks somewhat like this. Then what I need to talk about is, okay, what needs to happen to make it fit all the way back onto its original image? Well, back in the beginning, it said that it was dilated by a factor of r equals 1/2. To map it back onto itself, you have to remember that you use a dilated factor that is a reciprocal of the original. So the reciprocal of 1/2 is 2. So if I wanted to magnify this image, I would need to use a scale factor of 2. So that's my second step. Dilate by a scale factor of r equals 2, and I need to include the center point. And since it's connected here and I'm magnifying it out this way, point B is going to be my center point. And that's my total sequence.